Hey everybody, this is Larry. This is Friday the 13th. I actually didn't realize that during the daily problem. So I hope everyone's treating this Friday the 13th okay. I am going to do an extra bonus question today, a premium question or whatever that they give me. I'm going to just do a medium today. Um, yeah, maybe, yeah, I want to do a tree one. I don't usually pick one, but I usually choose a random one, but just to keep it theme, I don't know. I'll just keep it random. I am going to choose a medium just because we just did a hard, and I don't know. I want to go sleep or something. Oh, not an SQL table one. I probably could do it, but you know, I don't know. It just doesn't make sense. All right, cool. So today's problem, it's a premium one, so you know. Thanks for joining me, and you can check out these premium questions. But today's problem is 505, the maze 2. There's a ball in maze, okay, and empty spaces up, down, left, right, but won't stop rolling until it hits a wall. When the ball stops, it can choose the next direction. I feel like I did this problem. It's either that or maybe it was the maze 1 or something. It's really weird. I feel like I definitely have done this. I would also say that this, if y'all have been following my saga on Advent of Code, that this also reminds me a bit of a an Advent of Code problem in general, but you know, with practical things. Okay, so I mean, this is kind of tricky for a medium one, but maybe not really. It's just about it is just I mean, sorry, it's the shortest path problem is the answer. But I wouldn't feel like I've done this recently. I mean, clearly not, and I didn't have premium before, so maybe they just have a similar one that isn't premium or something, or maybe I'm just dreaming things up. But yeah, but it is a shortest path problem. It's just a little bit trickier to simulate, but it is still a shortest path. And in this, and there are probably two ways that you could do this one. Yeah, what is RNC? RNC is 100, so at most it would take 100 moves, maybe give or take. It's two empty spaces, okay. But yeah, but the idea behind this one, and there are two ways you can think about it. One is that each move, you don't have the decision to move until the next one, or or you and in that case all the distances will be one because well the ball is moving one step at a time, and then alternatively um yeah sorry, I'm just thinking through it. Alternatively, I don't know why I'm thinking through. I'm just tired maybe. I uh just to kind of celebrate a little bit of victories, I did heavy squats today, so I'm just like a little bit drained. But yeah, the other way is just regular dice draw where you know, like for example, this ball to go from its current position to the bottom, or not bottom, but like to go down, it takes two distance and so forth. So you can kind of calculate all these things. Um, yeah, and both ideas are right. I think I probably usually do it with Dijkstra or Dijkstra. People always correct me no matter how I say it. So today I'm just going to try to do it with breadth first search. The problem with breadth first search, to be honest, is that it may time out. So we'll see. I mean, I'm not like it's something that I know may happen, but yeah, we'll see. And if it does, then I don't know. Yeah, let's type it out. Oh, they give you the start. Wait, what is maze then? What is maze? Oh, zeros and ones, and then they just give you the start. Okay. Okay. I thought I had to pause the map to. I thought I have to. What am I doing? Is it? I want a deck, right? For B. Wow. Yeah, I thought I had to parse it out the maze is what I was gonna say for start and destination. You well, obviously not in this case, but very commonly they just have like a different enum or something. So instead of 0 and 1. Oh yeah, I also want to type out that up, down, left, right. Not necessarily in that order, and the order doesn't really matter anyway, so that's why. Okay, and then while length q is greater than 0, I know that we haven't queued yet. Yeah, let's add a. I want to add a helper function, but we're going to call it a million times. It's maybe a little bit slow, but oh well, whatever. Oh. Technically, I can write it to a tuple, I suppose. I guess I could write it this way. Just for consistency. I mean, it doesn't really change anything. And then maybe something like best of something like that, right? And then best of I guess I still have to do it is equal to 0 to start it off. Okay, and then now we have xy is equal to q.pop left for the next item, and oh, I have to do some stuff, don't I? It's not just this. I think I have to add one thing. Okay, fine. I messed this up a little bit, but that's okay. Because this best, there's an additional state, which is the 4 directions, right? Meaning that it matters whether the ball is going up, going down, going left, or going right, right? So yeah. Yeah, so we have to do that. So I just getting ping messages. Okay, and then here, yeah, let's just say, I guess there. Oh, I said 4, but I guess there's 5, right? Up, down, left, right, and then 1 for not moving. This is kind of yucky, actually, to be honest. Don't know how I feel about this. Maybe I will regret this in a little bit. We'll see. Because this is, you know, not it's getting what I don't like. Yeah, and then now D for directions. Okay, and then basically, okay. So now if D is equal to 4, then we can choose up, down, left, right, right? So then basically, nx and y is equal to x plus direction. Oh wait, in this case, for dx dy in directions, I thought I was going to write it a different way. Right, so and then now we have to make sure that it is within bounds, and also that it is not a barrier. Yeah, is equal to C. Which one's the barrier? 0 is the empty one. Then now we want to, and also that we haven't done it yet. Let's go direction. So then I can do distance is equal to best of xy direction. Oops. And if kicking it this way gives us a better direction, so if best of nx and y, not direction, but I have to enumerate this for the enum, I guess. If this is bigger than, now this is breadth first search, so as long as this is not none, then we have not done it before. Okay, and then we can do something like this. It's equal to distance plus 1, because we move 1 more distance. Does it have to stop exactly there? Maybe. Oh, Huh. I actually misread this one. Maybe web first search isn't the best way to do it then. I mean, it's fine. It'll just be really silly. Okay, and then of course we want to append it to nx and y, the new direction. Okay, and then else we just keep going, right? So nx and y is equal to x plus directions of let's see, what did I call it? Direction. Oh man, this is a mess, as they say. And then again we check if it's within bounds, if it's within bounds, and of course this is an empty space and we haven't been there yet. Then we travel. Else, so if it is either out of bounds for some reason, or if it hits a wall, this one's a little bit awkward actually, because I think I have to do something like I have to put this inside. Because this L should be if it goes outside, but you know, they're not. It's a tough one to kind of reason for, well, not reason for, just like remember, I guess. Okay, so otherwise, what this means is that we can move, so that means that the ball stops at x and y, right? So that means that we want to do something like is equal to distance. Oh yeah, and then best of oh, not this, and then append xy4. The only tricky thing about this though, well, one is that we have to check that we haven't done it yet, because if we did it, then you know, then we could just skip doing it. But the problem is that, as you can see, and I actually forgot, oh, I didn't realize this, is that in this case, the way that I structured it, this is distance plus 1, distance plus 1, and this is distance, and not distance plus 1. So actually what you want is append left. So this becomes a 0, 1 BFS, which is actually more complicated than I initially, I just didn't think it through. So this one's actually a little bit my bad. And then at the end, we can actually terminate early as well, which is, I think, here. If x is equal to, maybe something like this, is equal to destination, then we return distance. Keeping in mind that this only happens at direction 4, which means that it's my direction enum for it being stopped. So, yeah. And then otherwise return -1. Let's see if that works. I mean, it looks okay for the other two, but I think they just return -1, so so maybe I'm returning -1 for everything. Am I forgetting to do something? I mean, I guess we can just print XY direction, right? Okay, so it actually does something, just not the right thing, which is sad, but you know, such is life. Where am I trying to go? So we start at 0. Wait, what? Oh, okay. So the borders are actually not drawn out. It's just as implicit. Okay. So we go for 0, 4. We go to 1, 4, 0. That's not right, unless I'm misreading it. What am I printing? Yeah. 0, 4. This is a 4. Oh, no. 0 is the direction. Not, and I forgot that 4 is the not moving. 0 is not the not moving. So 0 is probably dropping 1. Yep. Okay. So that's good. and then so it stops at 3. Let me also print out the distance. I think I just confused direction with distance a little bit as well. I mean, it goes to 14, which is already too long. Do I have to do something like this? Maybe that wasn't. Oh yeah, okay, that was just silly. But because this is an array reference, but of course we shouldn't convert everything to. Whatever. Let's just write it this way for slight efficiency reasons. Okay, so that was kind of silly. I just kind of. It's very easy to make these mistakes in Python because they don't tell you like, hey, friends, you're comparing an array to a tuple because you're silly. Okay. I mean, actually, the running time was pretty okay. But yeah, so what's the running time here? Well, as I said, each cell on the maze is going to visit at most 5 times. 1 for up, down, left, right, and then 1 for stationary, right? And everything else is breadth first search. So. And everything else is all of 1 lookup. I mean, I guess this one's technically all of 5 or 4, which is, still all of 1. So yeah, so this is going to be, as I said, all times C, which is linear in the size of the input. So yeah, that's all I have for this one. Let me know what you think. And of course, space is also all times C, or all of all times C, which is linear space as well, right? You have just linear times 4 here. It's very stuffy in my coming today. 77 degrees. What is going on? It's like really cold out, but and quite raining. But I am just getting. Anyway, yeah, that's all I have for today. Let me know what you think. Stay good, stay healthy, to good mental health. Hope you did this extra problem with me, and let me know if you did in the comments. I'll see you soon. So see you later. Bye bye. Enjoy this Friday the 13th. Bye bye.